everyone, and welcome to Science in the Sky. I'm Katie Wolfson with the National Center for Atmospheric Research, and we are so excited to bring you this very special NCAR Meet the Experts and DMNS Science in Action joint program today. We are coming to you live from the NCAR Earth Observing Laboratory Research Aviation Facility here in Broomfield, Colorado, which I know is very close to some of our schools here. I believe we have a Westminster school. Hello, Westminster, you're right, our neighbors right now. And we have lots of other schools today from Colorado and Indiana and Utah. We're so excited to have you all join us today. We can't wait to hear your questions. This program is really special to us because we love connecting students like you to amazing experts like these two folks here I'm going to introduce in just a second in amazing science places like this research aviation facility. I want to start today by respectfully acknowledging that we are broadcasting to you live from the traditional lands of the Ute, Arapaho, Cheyenne, Oceti-Sakowin, and other traditional knowledge keepers. And the Front Range is the home to both current and historical indigenous peoples. So we are very lucky to be here at the Research Aviation Facility today. We are in an active aircraft hangar at an active airport. I have giant doors over here that we'll check out in a little bit. So there are planes taking off and flying. So please bear with us. You will likely hear some airplane noises in the background. You might hear a little bit of static on our microphones because there's lots of instruments because they are actively working on this really cool science plane behind us that we're going to get to check out today. All right, so if you need anything today, please type to us in the chat. We would love to support you however you need to and also take questions throughout the program, all right? We do have, I know at least one group who has on camera and will unmute later to ask questions. If you are interested in asking questions on camera, you can let us know in the chat too and we can promote you to an on-camera spot. We do have a few of those available. But stay muted until we call on you. Feel free to type questions or anything you need in the chat throughout the program. And I think that's all of the housekeeping nitty-gritty. Let's get to the fun stuff. So today I have two amazing experts for you to talk to. I have Janine Aquino, who is a software engineer here at NCAR, and also Andrew Green, who is an aircraft mechanic. So he knows all the stuff about this cool plane behind us. So I'm going to go and step off camera and turn it over to these rock stars. And Janine, do you mind telling us a bit more about where are we and why are we here?
Sure. So as Katie said, we're in Broomfield, Colorado, and we're at a hangar owned by the National Center for Atmospheric Research. So just big aircraft hangar with a plane in it. What we do out of here is we actually have a building full of scientists next to us, and we do research on the atmosphere. So we take this airplane, and it's a Gulfstream 5 jet, which we will let Andrew tell you more about later. But what we did is we took all the seats out of it. We left the crazy wallpaper that it came with, and we put in scientific racks and scientific instrumentation. And then we have, so you can see, a rack there. We've got computers on those racks that run the instruments. Some of the instruments are actually on those racks. Some of the instruments are on the outside of the plane, which we'll show you later. There can be ports. So we just did extensive modifications to this plane. And we take it and we fly it all over the world. So what happens is scientists propose, I want to study how hurricanes form, let's say. And so they propose to the National Science Foundation that, and if they get funded, we work with them, we figure out what instruments are going to help them collect the information they need to do that research. We outfit this plane, we fly to somewhere with hurricanes, and we do research. We have been almost all the way up to the North Pole and almost all the way down to the South Pole. We've been all over the world. So yeah, it's a fun place to work.
Wonderful. And why do we need to go up in the atmosphere to study it?
That's a good question. So you can imagine we can take measurements in place. Like if you want to know how hot your tea is, you might put a thermometer right into your tea. But sometimes you can do things remotely as well. Like from the atmosphere, we can do a satellite and look at the atmosphere from the top down. We can have radars that look at things by the surface. We have things that look up. But it's not always as accurate or what we need in place. So something in situ, as we call that, like putting the thermometer right into your tea. We can go right up in the atmosphere. We can measure the temperature right there, the pressure. We can collect images of particles. So we're flying through clouds and we can see what's the distribution of the sizes of the water droplets in that cloud. We can even collect samples of the air. So one of our instruments has got all kinds of bottles inside one of those racks, and they just run air into it from wherever we're flying, close it up, and then they take it back to their lab and analyze it to see, what are the chemicals there? Is there hydrogen, oxygen, iodine, all kinds of things?
Very cool. So just like another scientist might go gather soil samples from different parts of their garden or different parts of the city, then you can go and fly and take little air samples from different parts of our planet's atmosphere.
Yes.
Very cool. Well, we, I think, have a fun trivia question for our students on today. We are going to give you a poll question before you get to ask us questions. We want to ask you one. We are curious for you, how thick is our atmosphere? So if the planet Earth were a basketball, our atmosphere would be as thick as a fruit roll-up wrapped around it, a banana peel wrapped around it, or a blanket wrapped around it. How thick do you think our atmosphere is that this plane is helping us study? So teachers, go ahead and type in or poll your question, your students. If you have any trouble with the poll, you can also type to us in the chat. And let's see. Go ahead and get those answers, and we'll take just another few seconds. If the Earth were a basketball, our atmosphere would be as thick as A, fruit roll-up, B, banana peel, or C, a blanket wrapped around. Just take your best guess.
I hope it's not a banana peel, because my husband does not like bananas, and if the whole world smelled like a banana, he would not be happy.
Okay, I'm not seeing those results just yet. Oh, here we go. Okay, I just found the results. We have 73% say blanket, 18% say fruit roll-up, and 9%, say banana peel.
Oh no!
So, yeah, the correct answer is actually a fruit roll-up. If we were to scale our planet down to the size of a basketball field, where we are, where Mount Everest is, where all the weather happens, is only as thick as a fruit roll-up.
And I can see why you might think blanket, because the Earth's atmosphere acts like a blanket. It helps keep us warm, right? So you've heard that analogy before, I'm sure, but it's not the thickness of a blanket.
Okay, and we're seeing a cool diagram of all the different layers of our atmosphere that we can study here at the National Center for Atmospheric Research. And Janine and Andrew, do you mind sharing a bit about where does our plane, this plane behind you, where does that fly?
So, like we said, this is a G5. It is a high endurance. It started life off as a high endurance business jet, and it has an altitude of about 50,000 feet. So, if you look on that diagram there, where the spy plane and the commercial plane are, we fly just between that for maximum altitude.
We also have another plane, a C-130, that's not currently in-house. So we have two hangars here, and the other one is out getting some work done on it. There's a picture of it there.
Yep.
And that one actually flies about half the height that the G5 can fly, but it's a lot bigger, so we could put a lot more stuff in it. So we have two different planes that kind of help us do two different types of research.
Yeah, our C-130 flies at an altitude of about 29,000 feet, but we can also carry a decent amount of weight on it, and it has a really high endurance, so it can stay aloft for about 10 hours, which gives us a lot of time to circle thunderstorms or check out phenomena and just really hang out in the air doing some really cool science.
So kind of two different science tools that help us do different science experiments up in the air.
Yeah. G5 is high and fast, C-130 is low and slow.
I think you just saw a photo from the cockpit of the C-130 of it out checking for some wildfires, doing wildfire research. Okay, Janine, do you mind telling us a little bit more about what your job is here and what you do on the plane?
Sure. So I am a software engineer, and we have a computer network on the plane, not connected to the stuff that runs the plane. I want nothing to do with making sure the plane stays in the air, so we keep ours very separate. But ours, all the instrumentation that we fly, as you can imagine in the modern day, is connected to a computer. So we have programs that operate the instrument, tell it what to do, so it's collecting data, and then like where to point or how to move, or with those bottles, when to open and close the valve to collect the air. And then on the other side of that, we have to collect the information if it's not actual physical air, if it's measurements, and put those onto a computer. So I help write the software that controls the instruments. I help write the software that collects that data. I also write software that allows us to visualize that data for the scientists, so they can kind of keep an eye on their instrument and make sure that it's collecting the information they need to collect and that nothing's going wrong. If something is going wrong, they can, if they're not on the plane, sometimes they can fly, but if there's not room for them and they're on the ground, they can actually communicate up to the plane using chat. It's like texting on your phone, and tell somebody on the plane, hey, could you toggle that switch or reset that parameter, or maybe just turn it off and on again if something hung up. Yeah, and make sure that they're getting the data that they need.
Very cool. So even on fancy science planes, turning the instruments off and on again sometimes is the best way to fix it, huh?
That is number one. Yeah, it can be very helpful.
I think we can all relate to that here down on the ground. And Andrew, how about you? What's your job here?
So I'm one of the aircraft mechanics here, and what my job is to make sure that this plane is safe and ready to fly. So what I do is I will do inspections, I will do preventative maintenance, and if anything does break, I will go out and fix it. Before every flight, I always do a really thorough pre-flight inspection where I will check the tire pressures, I'll check our oil and hydraulics, I'll go through the wings and make sure all the gearing and everything behind the wings is not cracked or broken or anything like that. And yeah, just make sure that the plane is safe. I'll even help fuel it up and get it ready for flight.
Cool. So is an aircraft mechanic similar or pretty different from like a car mechanic?
Pretty similar. Some things are similar, some things are not. I actually joke with people that the airplanes tend to be a lot more simple, just because less moving parts, more simple, less likely for something to go wrong. So, and these planes are also built with plenty of redundant systems in there. So if one thing were to fail, you have another system to back it up.
Very cool. So we talked a little bit that we have two different planes that can carry some, I think you mentioned they can carry different weights. Mm-hmm. So we have another question for our students today. We are curious, how much weight do you think that the NSF NCAR G5 behind Janine and Andrew, how much weight can it carry? Do you think it can carry about 3,000 pounds, so about a VW Bug, about 5,600 pounds, which is a large SUV, or about 13,000 pounds, like a small school bus? What do you think could fit and be carried by this airplane behind? So how much weight can the G5 aircraft carry? 3,000 pounds, 5,600 pounds, or 13,000 pounds? Is it a VW Bug, a large SUV, or a school bus? I'd like to see you try to drive one of those onto this plane. If you're having any issues with the polls, you can also tell us in the chat. Oh, looks like we have some poll results. I am seeing, 82% say 5,600 pounds, and 18% of folks say 13,000 pounds.
You guys are correct. This airplane can carry 5,600 pounds, or a large SUV, which is still quite a lot of equipment for science experiments. The people who guessed the school bus, you'd be correct if that was our C-130. Our C-130 can carry 13,000 pounds, which is a school bus or an African bull elephant. And you can see on that picture there, yeah, it's got 4 engines, propellers, and is just a monster of an airplane.
Well, Andrew, do you think we can go try to check out the inside? Would you like that, students? Do you want to see if we can see the inside of the airplane? Okay, absolutely. So we do have active folks working on this aircraft, getting it ready for its science mission. So we're going to do what we can to stay out of their way, but we're going to go see. You might hear some static as we go on to the aircraft too, but I will turn it over to you, Andrew, to let folks know what we're seeing.
Okay, so like I said, we all know this is our G5. Walking around the front here, you can see all these different little probes sticking out. The lower two are actually airspeed indicators that tell the pilots how fast they're going. You've got a temperature probe up top to tell them how cold the wind is. Those 2 probes on the very top of the nose there, that's actually for the scientists, so they have an idea of how fast they're going, so they can calibrate their instruments to that. Coming around to this side too, we've got more temperature probes. I'll actually show this one is kind of fun too. This is our angle of attack. So this little vane here can move back and forth. This actually tells what angle the airplane is in direction to the wind. So if it's like this, that means the nose is probably up and it could be sinking down because the wind would be flowing this way. Straight ahead is usually obviously where you want it, but during takeoff, it would move like this and tell the pilots what angle the plane is to the wind. So that's always fun. Coming back over here, we'll go hop up on the plane. Yep. You can see right now that we have science experiments are being installed onto the leading edge. We have those pylons there with the pods attached to them. Some of the wires are hanging down, so they're waiting to install that instrument. Another thing about the plane is all the shiny bits you see that are facing into the wind that are forward, those are leading edges, and those are all heated to keep ice and snow melt and rain off of them. Any kind of contamination on the wing could cause you to lose lift, and that's why we actually pump hot heated air through all those chrome spots. So coming into the plane here, we'll look to the right and we'll see technicians and scientists getting their science experiments all ready. So you can see all the racks and everything we have. There's Kay, one of our managers. Coming back here into the flight deck. Make sure I'll pull up our displays here. So this is where the pilots obviously spend most of their time. We have our displays all up. I pulled up the navigation. What's cool about this is that this is actually called synthetic vision. So when the pilots are flying through weather and
So we might need you to come on out and tell us stuff from outside of the plane, unfortunately.
we can do that.
So everyone take a good look, see if you have some questions, and Andrew's gonna come back out of the plane and we're gonna take a look. We have some footage of it too. We have lots of science going on in that aircraft, and so I think we're just getting a little bit of interference with our mics, unfortunately.
Okay.
Okay. Awesome. So Andrew, do you mind telling us a little bit as you're walking back over about what it was inside that?
Yeah, so
cockpit?
what that was inside was the synthetic vision, which for the avionics, if we're flying through bad weather, the pilots can actually look on their screen and see what landmarks are ahead of them. So they can see mountain ranges, rivers, buildings, all that stuff. So it's a really good frame of reference for where they're flying at. Inside the avionics too, I can also pull up different pages to show what the plane is doing, like what the fuel levels are, what the oil and hydraulic levels are. Is the fuel getting too cold? Do we need to run heaters through it? All sorts of stuff like that. And then what the electrical power is doing. And then like if there's ever an issue, we can divert power, we can divert hydraulics. All sorts of stuff can be done from those displays.
I think we have another little video clip kind of panning up and down that if you want to take one more look at that. Let's see if we have that ready to go. There we are.
So yeah, that is the flight deck. You can see the controls, control pitch, roll. Radios are usually down there to the right. One thing that's fun to point out if you guys keep watching that is you'll see some of the knobs are actually in the shape of what they pertain to. So on the right side next to the throttle quadrants there, you'll see like a little white knob. That one there is actually for the landing gear, and it looks like a wheel. So when it's dark in the cockpit and you're flying at night and you need to find your landing gear, you can actually grab onto the wheel and be, yeah, that's the landing gear, and pop it down.
Looks like there's 2 pilot seats.
Yes.
So there's you 2 folks flying the airplane.
Yes, this plane requires 2 people to fly it. It is complicated enough that it needs 2 people.
And how many people can ride on the airplane total?
About 9. As big as this airplane is, it usually carries about 9, but that's also because we need a lot of room for all the science racks and all the equipment that goes into it. You can see that those racks do take up quite a lot of space.
So there you can see a team, and they're actually in flight in this video. Check out that view.
Mm-hmm.
That's so cool, how high up it's flying. All right, so I think we're gonna start taking questions now. So feel free to throw those questions in the chat. And then I know we also have Dodd Homeschool in our chat, or to ask questions on camera. So if you are able to turn on your camera and turn on your microphone, I would love to go to you for one question.
Yeah.
Or you can type it in the chat.
Cool.
While we're waiting for Dot Homeschool, we are going to, I do have one question here in the chat from Launch Ed is asking, I thought I heard something fairly recently about discovering our atmosphere actually extends to some extent all the way to the moon. So they heard that the atmosphere can extend kind of all the way to the moon. Have y'all heard that?
I have not yet, but that's a great question.
Yeah, and it kind of makes sense, right? Because it's not like there's a hard edge to the atmosphere. At the surface, where there's more gravity, there's thicker atmosphere, and it gets thinner and thinner as we go. And so I think the definition of the edge of the atmosphere is got to be something about whether, how many atmospheric particles still exist. And maybe they've recently discovered some go as far as the moon. I don't know.
And I do remember hearing too that our atmosphere can expand and contract based on what the sun is doing too. So if it's expanding too much, ISS has to fire some thrusters to get to a higher altitude. So yeah, that's a really good question that I want to go look up now.
So that's pretty neat that they're still studying that, right? It's not a known thing.
Very cool. Yeah, I believe about 99% of our atmosphere is within 50 kilometers of the surface of Earth. But yeah, it just kind of starts getting thinner and thinner and thinner the further out. I think I've heard that it can go to at least halfway to the moon. But yeah, maybe they're finding some of those atmospheric particles all the way over by the moon, which is very cool. Thank you for sharing that with us. Okay, so it looks like our in-camera folks don't have a question yet, but we would love, I know we have lots of curious folks on there. We would love to hear any questions from you about the plane, about anything you're seeing or wondering, anything you've heard, maybe something about the weather. We have another question here. Is it more difficult to fly at a higher altitude than when you're at a lower altitude?
It's usually, well, it depends on the engine. Jet engines like what we have tend to fly much better, more efficiently at higher altitudes. There's less drag, there's less atmosphere. The jet engine's fuel ratio burns at what's called stoichiometric, which means that it's getting a good burn of both fuel and oxygen. So the jet engines are great at high altitudes. If you're flying a little 172 out here, a little piston-powered aircraft, they tend to fly much better at lower altitudes, just because it's easier to get better fuel efficiency with having more O2, more oxygen going into the engine. Our C-130 is great because it can do both. It's got propellers on it, which are incredibly efficient, and their propellers are basically attached to what is a jet engine. So for us, the C-130 is best of both worlds.
Wonderful. Okay, I'm seeing some more questions coming in. Keep them coming, everybody. So we have a question from Michael Lewis's group asking, how often do you fly missions?
Oh.
So we get funded to do research with these planes about 3 times a year, I would guess, on average. Sometimes less, sometimes a little more than 3 or 4, and it's just too much work for us. We can't support that, because each project is a lot of work. But yeah, so maybe about 3 times a year we fly, and then individually, I don't particularly like to fly on the plane. So I might go out to the site where we are and then deploy on the ground and support the plane from the ground. I can actually log in from the ground to the plane and look at things. So I prefer to be sitting in my hotel room or in a coffee shop or something and monitoring the flight. Or I think Andrew prefers to be up in the plane flying around.
Yeah, I do enjoy flying. Actually, some of those pictures you see right there, I took on one of our last science missions we flew over the summer. We were trying to find spicules, which were just incredibly small, hard to find droplets of water that didn't freeze and then crack, and there was a whole thing to it. And we had to chase the edges of thunderstorms, and so we were in turbulence the whole time, and I enjoyed it because the sun started setting, all those clouds were lighting up, and it was just so cool to spend that much time in the air flying around chasing a thunderstorm.
Oh, no turbulence for me. No, thank you.
Yeah, there's a good video of it. So we were, you can see the thunderheads there. This video is sped up about like 15 times. But yeah, so we would fly through the clouds. We would get measurements from there. And keep in mind that when you see those kind of clouds, it's usually rough air all around them. So we were just getting beat up the whole time.
But look at that view as you go. And I think that camera you were seeing that view from is actually on the wing right over here.
It is, yeah.
Us.
We have 3 cameras on the airplane. We have one that points forward that's mounted on the wing. We have a downward facing camera and one for the left and one for the right. And depending on what the scientists want to have available, we can fly one to all 4 of those. and collect imagery. That's more like just for, understanding situational awareness. Are we in a cloud? Are we not in a cloud? For the scientists to maybe recall during the flight, oh, there was a certain phenomena, that's when we flew through it, so that they can identify the best data to do their research with. And with those videos, when we do them for research purposes, we can also include data and plots along the side of them. So maybe temperature, say, so that they can see how hot or cold it was and pick a portion of our flight that was in the right temperature range for the research they want to do.
All right, we have a question from Henryville Elementary in Indiana asking, how heavy is the plane behind you? We talked about how much weight it can carry. Do you know, Andrew, or have we stumped you?
It actually stumped me. Off the top of my head, I cannot remember what the full weight is. I know we carry about 40,000 pounds of fuel. I cannot remember what the empty or gross weight of this airplane is. I would have to look that up. Usually before we fly, we will calculate that out, and that's usually a pilot thing. We'll tell them what the weight is, and then they'll tell us how much fuel to put on.
So you actually change the amount of fuel based on the weight of the plane?
Yes, and we will also, the weight changes too with all the science racks that we'll put on it. So before every science mission, we will actually weigh the airplane, so the pilots know where their center of gravity is and all that. And weight is actually a great question. Weight is actually crucially important to know. Over this last summer, since it was so hot up here, the air was less dense, and it's called density altitude, where the hotter it is, the more your plane is going to perform like it's at a higher altitude. And we were actually, with all the science equipment and everything on it, we were actually too heavy to fly out of here. So we had to skimp on fuel, get into the air, go to Texas or Kansas to refuel, and then fly our science mission.
So a lot of different parameters and skill that goes into this from all sorts of people working on this aircraft. That's really great. Okay, we have some more questions. We have a question from Morrison, Colorado, from Carrie asking, you said that the scientists and the pilots have different speed indicators. Is there a reason that they use different speed indicators?
So
maybe you can remind us what those are.
Yeah, so for the pitot tubes right there, those speed indicators are just for the cockpit. For the scientists, we don't really want to tap off of any systems that were already integral and first put on the airplane. So the speed indicators for the scientists are up on top. That's just their own independent system. So the speed indicators that control the avionics and go directly to the cockpit aren't bothered by the other ones that we installed.
And for people like me who are working with the scientists, maybe we want to do some different calibrations on those measurements and speed or temperature or different things. I don't want anything to do with touching anything that makes this plane fly. That's Andrew's job. I don't know about it. I don't want to mess it up. I feel very happy that I have no access to any of that.
Oh, wonderful. Okay, we have another question from Launch Ed in Longmont. They're curious to learn more about how do they get the hot air to go into the wings to stop it from freezing? How does that work, Andrew?
So that is called the bleed air system. If you guys look onto our engine right there, all the air is getting sucked into that engine, and it goes into what's called the cold section first. That cold section compresses the air down. And when it compresses down, the temperature will go up, actually to 400 degrees, which is kind of comical because it's the cold section. And the engine is so good at compressing air that we actually have to take air off of it, otherwise we'd rupture the case. So we have what's called bleed air, and we use that to not only heat up all the chrome surfaces of this, but also pressurize and keep the cabin at a good temperature.
Are there tubes and such within the wings?
There are tubes in the back of the plane. There are actually radiators to cool the air back down and to get it at a comfortable temperature. The bleed air system is pretty complicated.
Really neat. Okay, we have another question coming in the chat of they're wondering if there are any unique elements that are found at higher altitudes. So do the elements in the atmosphere change as you look at different parts of it?
I don't know the answer to that question. I would imagine based on all kinds of atmospheric phenomena, they're different. There probably are changes, but I don't know.
I think I picked the brain of one of the scientists, and they said that the UV light can mess around with some of the chemistry up there. So yeah, that is a wonderful question. We'll have to tag one of our scientists for that.
Yeah.
I love it. You stumped us with that one, but that is so cool. But can you remind us, the Tiger project, that's looking at a specific element of trying to look at it, right?
Yes.
Yes. Yeah, that was looking at iodine in the atmosphere. So back in the 70s when we banned 70s and 80s when we banned CFCs that were damaging the ozone layer, the ozone layer started to regenerate, but it hasn't been regenerating at the rate scientists originally thought it was. And so that's what this science mission is that we're going to see if maybe iodine has something to do with it. And we can later on, we can tag one of our chemists and they can tell us a little bit more about that.
So yeah, a lot of the science with atmospheric chemistry, we use models and things. So we use lots of math equations and supercomputers to make models of what we think is going to happen. And so yeah, they're trying to look at why does our model that says the ozone should be healing up a little bit faster, it's not quite doing it at that rate. So maybe we need another piece of information in our model, like iodine. So that's what we're going to apply and check out. Okay, we have so many great questions in here. We have Ella Kratz is curious about do you know what it's like to fly in a hurricane?
I personally don't. I've heard the stories about it. I know this plane has been tagged before to fly over the top of hurricanes and drop what's called dropsondes into it, which are little computers basically that will start at the eye of the hurricane and go around the hurricane and drop them at certain points. And these computers will fall through the air and measure everything going down until they hit the ocean and give all that data back to us.
Now, the NOAA is a different government organization, and they fly what they call the Hurricane Hunters, of 3 airplanes that are called Kermit, Miss Piggy, and Gonzo,
Yeah,
I believe.
Gonzo's one of them,
Yes,
yeah.
so they mainly do that work, and so that's not our job. But occasionally when one of their planes is getting repaired and they need some help, we'll go. We don't do the flying through that they do. We don't have that expertise, but we can either fly above or around, drop these dropsondes and get them some data to help them with their predictions of what that hurricane path is going to be.
Wonderful, and I imagine it is pretty bumpy going through that. It's a bumpy
I
flight.
imagine.
Okay, let's see. We have some more great questions here about how long does it take to build the airplane?
A couple months. I'm really not too sure how long it does take to build. Keep in mind too that this originally started life off as a business jet. So if you wanted to go out and buy a G5, you'd go to Gulfstream and then you would also get to customize your entire interior and all that. We opted not to do that. We decided to just go with a bare bones interior, and then we sent it to Lockheed Martin to get modified. So Lockheed Martin then tore the plane apart and cut in all the viewports and all the other stuff that you see. So like those 2 probes on top of the plane, those had to be specially cut out and modified, structurally modified, so we could put those probes up there. Same with other viewports underneath the wings or underneath the plane that has really specialized glass, and also the wings had to be reinforced too to get those pylons put on.
Gotcha. Can you tell us a little bit more about those pylons and what those are and what they have on them? What are they for?
Yeah.
Sure. Yeah. So under the wings, we added these pylon connectors. I'll walk over here. And we have 6 canisters, we call them, that we can put instruments in. So we definitely have an instrument here and here. The other ones look like there's nothing in them at the moment. I'm not sure what will get added before we're done completely for the project. This one's called a microwave temperature profiler. And this is actually one that I've been doing a lot of software development for. And then this one here with the blue is microwave temperature and humidity profiler. So they've got one extra measurement that we don't have. And so yeah, I've helped for this project, I've helped develop software that allows the microwave temperature profiler to be operated and for it to be observed by the scientists to look at the data that's going in. It's got inside of it, so microwave, it's the same as like your microwave at home, heats up your food. So that wavelength is a temperature wavelength. We can use it for temperature. So we can do that in the other direction in the atmosphere. The microwaves are in the atmosphere. Things have temperature. They emit a microwave radiation. We can pick that up and find out what temperature they are. And so this thing scans. It goes across 10 angles. It's got a little mirror inside of it. I'm not sure if we can show you that. Okay, come back here so I can see. Yeah. So kind of on the lower left of that image is kind of a round thing. It rotates around, goes 10 angles forward facing, and then one back to something that's a target that's like for us to calibrate so we can keep our temperature correct. Then around, and what that does looking out is it gets like a vertical picture of what's going on in the atmosphere, just a profile, a single column of temperature at 10 different heights. And then as we're flying along, we're in another place, we get another 10 heights, and this comes together as a curtain that's kind of the track of the airplane, and we can get a whole sense of what we flew through and what the temperature was of the atmosphere. And that's useful, say, the chemists doing their chemistry helps them understand, well, what reactions are going on, those are affected by temperature. The other instrument also has humidity, which we don't have. So humidity is just moisture, right? How humid it is. You hear that on the news. It's going to be a humid day today or whatever.
Great.
Yeah.
And so why would we have a second one looking with the additional humid of how much moisture and water is in the air? Why do we have two kind of similar instruments on the same plane?
So for this project, Tiger, another component of it, other than the stuff that Andrew talked about with the iodine, is to test some new instruments and to develop their capabilities. So we have two instruments so that we can compare them to each other. So we can't compare the humidity because we don't have that, but they can compare their temperatures. They're flying on the same plane through the same environment. They should get a similar result, but we can see if they're working accurately, and we can also compare them to other measurements we have. We're looking for error in that kind of a thing. So let's say you step on the scale in the morning and you weigh 95 pounds. You probably don't weigh exactly 95 pounds. Your scale's not exactly accurate. Maybe you weigh 97 pounds or 94 pounds. So if you went and stepped on 10 different scales, one after the other, you might get a sense of, what's my real, oh, that scale said I weigh 105. Well, that one's all messed up, you know. But these other ones all, okay, if I can kind of see, mostly, I probably am pretty close to 97. Maybe I'm really more like 98. I don't know. So that's what we're doing. We compare a bunch of instruments and try to understand what are those errors, because those errors propagate through our science. You know, we use the temperature, we combine it with something else that has an error, so then you have multiple errors, and you have to try to get a sense of how accurate is the science we're doing.
Wonderful. Okay, so we have more questions coming in here, which I love to see. We have just under 10 minutes left, so let's see how many questions we can get through. We have a question of, what is the longest mission you have taken? Or do you know what the longest mission of the plane?
For one single flight, I don't know, but I know that we did for over 3 years, we had 5 missions, and we didn't do it all in one flight. We had to stop as we went, but we started here in Broomfield, and we did multiple flights up to the North Pole, then all the way down to the South Pole, and then back. And we did that 5 different times in multiple seasons because they wanted to understand how the atmosphere of the whole planet was changing with the seasons and across the whole from north to south. We called that project HIPPO. Everything gets an acronym for us. So it was high altitude, I can't remember the whole thing. But that was our HIPPO project. So we had 5 HIPPO projects.
Yeah, and this G5 has an endurance of about 7 hours. And I think last summer I actually helped out with a flight where we had to refuel twice. And so it was an incredibly long day, but it was still so much fun because we got to see so many things from the air and we got so much data. It was great.
Yeah, our limit actually really is fatigue. We have limits how long we're allowed to fly because when people get tired, then things aren't as safe, right?
Yep.
We need to keep ourselves alert. So there's a limit to how many days in a row we can fly, how many hours a day we can fly, how close one flight can be to another, so that everybody gets plenty of rest between flights.
Yes, this airplane can definitely outfly us.
Yeah. Very neat. Did the two of you get to travel very much with your jobs?
Yeah, we do. You can go.
Yeah, so this next trip is going to be in Kona, Hawaii, so I'm really excited about that. I get to travel with them, and we'll get to go to Hawaii. We'll be working the whole time, so it won't be too much time on the beach, but yeah. And then you have that really cool story of being in New Zealand.
Yeah, so a few years ago, I got to go with the plane to New Zealand, and like you said, we work a lot, about 6 days a week, but on the day off, we can go explore things. And these are seal pups. So the parents drop off their babies at a little stream at the ocean, and the seal pups work their way up the stream to this little waterfall, pool at the base of a waterfall, and they frolic and they play all day long. And then kind of the like daycare, except for there's no parents around, and then they work their way back down and they meet their parents at night. Their parents have hunted all day, maybe they have dinner available for them, do whatever they do, the sea lions do in the evenings, and the next day they come back. So you could hike up this little trail, it's not very far, you can see the seal pups along the trail, and then you can see them at the top just frolicking and playing and rolling in the water. It's extremely adorable. When I was there, I actually was able to take my husband along, and I told him that this was going to be cute, and he was going to be cooing, and he's a big guy, he got there, he sounded just like all the rest of us, just cooing, oh, they're so cute. So it was pretty adorable.
That is so neat. I love that. Okay, we have a question here from Morimoto, it looks like, that is asking you, what kind of education and training did you need for your jobs?
Cool. Let me just start off.
Yeah.
Yeah, so for me to get this job, I needed an AMP license, which is an airframe and power plant license. I had to, after I got out of the military, I went to school for that. So I learned how, all the rules and regs, all electrical theory, all sorts of stuff to work on aircraft. And there's a picture of us working on the C-130 propeller. So yeah, to do that, I had to go to school and you have to get certified to be an aircraft mechanic.
And for me, I took a bit of a non-standard path. I actually got a degree in physics, and I thought I wanted to do research on stars. So I got a job with NCAR here in the solar physics division. I am actually not much of a night person, I figured out after I got my degree. So studying the star that's up during the day, the sun, was the perfect thing for me. And from there, I started learning my computer skills on the job. I took some classes at night, online classes, taught myself stuff. And just over a 30-year career here at NCAR, I slowly moved over from kind of doing research to research support. I decided I'm not really much of a PhD scientist. I'm not good at coming up with that theory, but I'm really good at helping the person who comes up with the theory figure out, collect their data, analyze data, and figure out what they need to figure out to do that research.
Wonderful. We also have a comment in the chat from Ella saying, thank you for your service, Andrew.
Oh, thank you.
And we have a question asking, do we ever observe anything like planets?
I don't think that with these airplanes, we look at the sun. We have done eclipse missions where we're actually doing solar physics from our solar physics group. But beyond that.
Yeah, I don't think we're going to look at planets, but that just reminded me, there was an experiment years back checking out sprites.
Yeah, so this is.
Those are some cool pictures. So I remember hearing about that one was when you have a big thunderstorm, you have the big lightning and electrical discharge going down. You'll also have lightning coming off the top of it that's really hard to see. And so we did an experiment where they were flying around thunderstorms at nighttime, and they actually captured like red lightning coming up off the top of the thunderstorms.
Yeah, that was pretty neat.
That is
really neat
super
pictures.
cool.
We can
Yeah,
try
and
to
you
find
can
those
see
pictures and
you
send them
can
to
see
guys.
in this altitude diagram that's in the mesosphere that those sprites happen. And yeah, definitely go ahead and look for those.
I'm sure there's
online.
images online.
Yeah.
Yeah,
Find
they're
images, yeah.
Yeah, that's a great thing. So yeah, so mainly we focus on our own planet here,
Yes.
Earth, right here. So we're all about our Earth observations.
But not to say that things from space can't affect our atmosphere.
Yeah, and there's other places with atmosphere too that are studying our atmosphere might help us learn about atmospheres in other planets. All right, so we also have a question here of what did you study on your last mission? Do you know what the last mission the G5 went out on, or the last one you worked on?
Was that Costa Rica?
No, I think it was methane air.
Oh, right. Since then,
Yeah.
so yeah, our last international mission was Costa Rica, but since then we've been doing projects out of here. With COVID, we had to worry, couldn't travel internationally for a while. So yeah, methane air, as you can imagine from the name, was studying methane right here on the Front Range. So flying over, I
Oil
think,
fields and
yeah.
landfills and all that. Yeah, that I actually got to fly with two of those flights, which was a lot of fun because we went up to about 50,000 feet and then just went over oil fields and anywhere where methane could be emitted. And they had like an infrared laser camera that was measuring all of it. And it was so cool because at that altitude, you can almost make out the curvature of the Earth. So it's really cool.
Great question. And then I think we have time for one final question, and then we're going to say goodbye. But do you have a favorite part of your jobs, Janine and Andrew?
I would say the travel is a pretty big bonus to working here. Yeah, it's kind of fun, both for seeing a unique and different place, which is always great, but also the teamwork and camaraderie that comes together. We have a short period of time to collect information. So you can imagine for a scientist, they might spend 3 years preparing for a project. Then we go out into the field for like 6 weeks and we have to collect all that data that they need. And then they're going to come home and spend a few years analyzing it. So there's a little, pressure to make sure we get that done. So we come together as a team, we solve problems that happen in real time and work together to make sure that we can get them that data so that they can go home and do their research.
And yeah, same thing. I love all of it. I love when the science come in because then I get to pick their brain and I just get to keep learning about new things. I love spinning wrenches on this airplane. I love spinning wrenches on the C-130. And I also love that I get to travel and fly with them. I love that I get to be mission support for this, and actually, kind of help advance science in my own way. So yeah, this is a great job.
All right, thank you so much for all of your questions, everyone. Janine and Andrew, do you have any final words of advice or things you want to share with the students before we say goodbye?
Yeah, absolutely. So one reason why we wanted to do this was that we wanted to show that you can help out science and you can get into the science field without having to have a PhD. Like I said, I'm an aircraft mechanic and I get to spin wrenches on this and have a lot of fun. And I also get to help advance science. Yep.
Yeah, so for every scientist who goes into the field, there's 6 or 8 other people who go, who are helping support that. They don't all go into the field, but there might be a project manager who's helping us figure out, where we're going to store the airplane in the hangar and what hotels we're going to stay in, and clearances with the airports in the place that we are. There's people like Katie who are helping us share our science with you guys. Just all kinds of jobs. There's aircraft technicians who are actually working us with the got a plane flying by, with the electronics on the back of the plane. So if you like science and you want to help support science, but you don't think you're a PhD scientist, that doesn't mean you can't get into science. There's lots of different jobs available.
And there's also nothing saying, too, you can't get your degree later. I'm actually personally working on my geology degree. I'm working my undergrad geology degree right now.
Wonderful. Thank you both so much for telling us about your job, showing us around the Research Aviation Facility. Thank you, students, for your fantastic questions. It was so much fun connecting with you from all over. We hope to see you on a future program with the Denver Museum of Nature and Science. The next program for Scientists in Action is on April 7th, Ancient Mummies, New Discoveries. And then here at the National Center for Atmospheric Research, we also have a free program, Meet the Experts Networking at the Speed of Light, on April 20th, where we'll be talking to a network engineer about how we send data over light using fiber optics to high-speed internet and network. So we really hope to see you on either of those or both of those free programs. We'd love to see you, and maybe we'll see some of you in the future working here at the Research Aviation Facility with Janine and Andrew. So students, feel free to unmute and say goodbye, and we'll see you next time.
Thanks, guys.
Bye, everyone.
Bye.